All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, the answer is going to be x plus 11 and x minus 5. For the math knowledge question, it asks how many different values does it equal 0.2? 0.2 is approximately right here. Here's 1 up here, here's a half. 0.2 is here. This is the y value. So we're looking on the y-axis. And so if you draw a line approximately at 1.2, that may be a little bit high, but how many different places does your graph hit that? Well, it hits it one place here, one place there, one here, and one here. So a total of 4. So E would be your answer. Okay, so we're going to look at lesson 7 today, the unit circle, centerline, amplitude, phase angles for sinusoids, period of a function, and exponential functions. So we've already briefly talked about the unit circle. That's dealing with your 30, 60, 45 degree angles in the first, second, third, and fourth quadrant. I told you you might want to start looking back at those so that you can refresh on them. The sinusoids should be review from pre-calculus. Periods of a function should also be review. And then we're going to look at important numbers and exponential functions towards the end. So the unit circle is a circle whose radius is 1 unit. That's why it's called the unit circle, because the radius is always a 1. So on this circle, it is a unit circle. So the radius is 1. We want to find the coordinates of point P1 and P2. So we'll start with point 1, P1, and we're going to draw a triangle here. We'll make a right triangle. And this pi over 3, we already talked about converting that into degrees if you need to. That's the same thing as 60 degrees. And so this isn't a normal 60 degree triangle because our hypotenuse is a 1 instead of a 2 because it's a unit circle. So if I go back to my 60 degree triangle, where this is the 60 degrees, this would be a 1, a square root of 3, and a 2. Basically, you're just going to divide all of your 3 sides on this little triangle by 2, since we need to go from 2 to 1. So this side length is going to be square root of 3 over 2, and this one is going to be 1 over 2. And so the coordinates for P1 are going to be 1/2 square root of 3 over 2. This is basically the cosine of 60 degrees, and this one is basically the sine of 60 degrees. So if you want to do it using that information, you can do it that way. For this one, our triangle is going to be over here. And so we're not going to use the 135 degrees. They told us we went around 135. To finish out our straight angle, this part here is going to be a 45 degree angle. And again, we're not going to use 1, 1, and square root of 2 for our 45 degree triangle. This is going to be a 1 over here, sorry, because it's a unit circle. So it's not 1, 1, and square root of 2. So we basically need to divide all of our side lengths by square root of 2. So 1 over square root of 2 for this side length, 1 over square root of 2 for this side length, which again, if you rationalize, square root of 2 over 2 for both of those, whichever one you want to put over here is fine. So the coordinates for P2 are going to be negative square root of 2 over 2, negative square root of 2 over 2. And it's negative because we went to the left and then down. Negative 135 If you add 360 to that, it's actually going to be 225. And if you had started over here and worked your way around counterclockwise, that would get you to a 225 degree angle here. And so this is the same thing as cosine of 225. And this one is the same thing as the sine of 225. So you can help use that information to get your two answers. So that's how you can find the coordinate values for your points on a unit circle. Now we're going to go on to sinusoids. We're going to talk about centerline, amplitude, phase angle. Last year, if you had me, we learned Caspa. The C was for centerline. The A was for the amplitude. This is your function, whether it's sine, cosine, or whatever. The P is your phase angle. No, your period. Sorry, I don't have that one yet. We're going to do period in a minute. And then the A is for the phase angle. We'll go over the period after we do the centerline, amplitude, and phase angle. If you have had another teacher teach you this, then you probably learned some variation of this formula or this one with A, B. Sometimes people put a C in there for the period, and that would be in between the parentheses and the end of the sine or the end of the cosine. So that would be what your period would be. So if you recognize that formula, that's what we're looking at. So last year we talked about sine. It always goes through the center of the origin here. For cosine at the origin, it's going to hit a maximum. And then the period for sine and cosine is 2 pi. So if we went from here, one period is going to look like that. And for cosine, one period is going to go from a max to a max. Basically the same starting point until it starts repeating itself again. So that's your period. But hopefully you remember your center line, your amplitude a little bit. Center line on this one is 0 because we're at 0, and the amplitude is 1. Same thing on this one. We're at 0 for the center line, and amplitude is 1. These are your basic sine and cosine graphs. So we're going to go back over these to kind of help you review just a little bit. First off, this one has a center line of 0. So you don't have to write the 0, but you can if you want to. Most of you probably wouldn't normally do it. From 0 to 4, to go up, how far is that? That's an amplitude of a 4. So 4, and then is this sine or cosine? If we're going through the origin, it's going to be sine. And then quickly, our period is 2 pi here. And so we just have theta. And so some of y'all last year probably would just write y equals 4 sine of theta, not put the 0 plus. This part isn't really necessary. Okay, for this one over here, again, the center line is a 2. So we start with center line, and then our amplitude, we go up from 2 to 6 is 4. We're going through the origin, so that's a sine. And then our period, we go from here over, that's 1 period, which is 2 pi like it's supposed to be. So that is your equation. For this next one, the center line, sometimes it's hard to tell if that's a -6 or a +6, but if you look, it's in between -8 and -4. So y equals -6. And then from -6 to -4 is 2, so we went up 2. For our amplitude, it's again going through, so that's a sine. And then your period is again 2 pi, so you have a theta there, so that's your equation. Now this one is different. They don't tell us what the number is here. The center line is always going to be halfway in between these 2 points. So 5 plus 10, 15 is 20. and then divide by 2 gives you 10. And if you check, 10 is halfway in between 5 and 15. So that's how you can find your center line if they don't tell you what it is. So going from 10 to 15 is up 5. And so I'm going to make this one a sinusoid, a sine curve. So that means that normally sine is going up at the origin, but I'm going to put my fake origin right there. And I'm going to have to figure out what that is. So we're going to do an open parentheses and a theta, and then I'm going to leave a space and put a closed parentheses. We're going to put some degree in right here. So if you look, we're going from 60 to something to 240, and then we're going backwards to something to negative 120. The difference between these numbers is 180 every time. And so the difference between this one here to this one would be 90 degrees. And if I took 60 and added 90, I'd have 150. And if I added 90 again, I get to 240. So if I subtract from 60, I subtract 90, I'm going to get negative 30 degrees. And if I subtract another 90, I get to negative 120. So this angle here is negative 30 degrees. Now if you go back to the formula real quick, it's always theta minus the phase angle. So we're going to have theta minus a negative 30. So it's really theta plus 30. It's always the opposite of what you would think it would be. So that's a quick review over those sinusoids. The book has a couple of more examples if you want to look back of review questions on page 38 in case you've forgotten a lot more of that one than you realized. You can also do this one in terms of cosine. So I'm going to do it in terms of cosine. Y equals, the center line has not changed, the amplitude has not changed. The only thing that changes is the cosine and then the angle here. So now cosine always hits a maximum. You want the maximum that's closest to the origin, which is right here. And it's 60, and it's always theta minus the angle. So theta minus 60 degrees. So that would be how you could write it as a cosine. Sometimes they'll ask you for it in terms of sine or in terms of cosine, and sometimes it just says what is the equation. So if it doesn't specify, you can pick whichever one you prefer. So we're going to graph these now. So go ahead, if you need to, y'all can pause the video for a second while y'all graph them. Y'all have lined paper. What I recommend doing is just doing a little sinusoid over 2 lines, and that'll help try and make it as even as possible. You can tell what a lovely job I do drawing sinusoids, so I'm not as concerned that you make it look perfect, but I mean, you should put a little bit more effort than that to make it look a little nicer. I usually just trace one out of the book so that I have a pretty one if I'm going to have it in my notes or something. So if you want to do that, you can do that as well. So the first thing you're going to do is your center line. So our center line on this one is the negative 3. All right, our little mnemonic. Center line is negative 3. Our amplitude is 5. So negative 3 up 5 is going to be a positive 2. And down 5 is going to be a negative 8. This is a cosine. So our angle, it's always theta minus the angle. So our angle is actually 45 degrees. So the angle that goes here is 45 degrees because cosine normally hits a maximum. And it's telling you instead of it hitting a maximum at the origin, it's hitting the maximum at 45 degrees. And so now we're going to go forward 360 degrees, forward 1 period, which is going to put it here. So 360 plus 45 degrees. is going to be 405 degrees. And then each of these little tick marks occurs there are 4 of them in between. So they're going to occur every 90 degrees. So you're going to say 90 plus 45 is 135 degrees. Then you're going to add another 90, and you're going to get to 225. Then if you add another 90, you get to 315, and then you add another, you should get to 405. Now we need to put our axes. So this one is theta, so I can just come over here and put a theta. If you want to erase this part over here, that's fine. We don't need it. You just need to show at least one full period, and you also need to show where your y-axis is. So we have our theta axis, or our x-axis. So I need to go backwards. 45 minus 90 degrees is going to be negative 45. And so my y-axis is going to go exactly halfway between these two because it's at 0 degrees. And so you draw your straight line for your y-axis, and that's your graph. You do need to make sure to put the angle measures at each one. Sometimes the answer key doesn't have them for every single one, but I want you to practice doing it so that you can make sure that you're going from the 45 to the 405 correctly. Okay, so we're going to look at another one. We're going to start off with our center line, and then amplitude. Our function is sine. We don't have a period, but I'm just putting it for now. So center line is -3. The amplitude is 4. We're going to come back to that negative. So if we go up 4 and down 4, that puts you at 1 and -7. And then on this one, the angle here is going to be a -45 degrees because it's x minus the angle. So it's always the opposite. And so our angle we're going to use is -45 degrees. And this is a negative sign. So a positive sign is going up through the origin. A negative sign is going to be going down through the origin. So here's one, and I'll put -45 degrees here. Again, we are not dealing with the period change, so just go across one period, and that's going to put your angle here, -45 plus 360 at 315. Again, these are going to occur every 90 degrees, so -45 plus 90 degrees is 45 degrees, plus another 90 degrees is 135, and then if you add another 90, you get to 225. So we have one full period shown, and we also have our y-axis information. It's going to be exactly in between these two. It's always going to be in between your negative and positive numbers, and you can estimate it. On this one, it's exactly in between because it's -45 and +45. If it's -30 and 120, then you'll just have to estimate it as best you can. So that's your y-axis, and then the other one we need to put, it's x on this one, not theta. So you put x. And again, if you want to erase the part over here, you can. And you can erase this part of the curve over here if you would like to as well. It just depends on how much you draw. So that's how you would graph that sinusoid. So we're going to look at one more. We're going to do CASPA, and if y'all would like, y'all can pause the video and try this one by yourself if you feel confident in it. I'll walk through it, but y'all are welcome to pause the video and go ahead and try it by yourself if you want. So the center line is 2. The amplitude, we go up 3, so that makes it 5, and down 3, that's at -1. Our angle is going to be 30 degrees, and it's a cosine, but it's a negative cosine. So instead of hitting a maximum, it's going to hit a minimum at 30. So here's a minimum, so this is going to be 30 degrees. There's no period change right now, so come over one period. You're going to add 360 to make that 390. So if I add 90 degrees, I get to 120. If I add another 90, I get to 210. If I add another 90, I get to 300. And then if I add another 90, I get to my 390. Now I don't have a negative number, so I need to subtract 90, and if I subtract it, I get to negative 60 degrees. So it's going to be closer to the 30 degrees when I draw my y-axis. It's going to be more, whoops, like over here. So there's my y-axis, and then this is my theta axis. So hopefully that's what yours looks like for graphing that sinusoid. So now we're going to use our graphing calculator to graph the equation that we just graphed in 7.4. And we want to make it show the same x and y values as what we just did in our graph. So I'm going to go back to that graph so that we can see it. So we want it to match up like that on our calculator. Alright, so go ahead and grab your calculator, and we're going to go to y equals, and we're going to type in the equation for this example. 2 minus 3 cosine. Now, we have theta. If you look, there's a theta here, but when you type that button or hit that button, it goes to x. That's okay, because we're going to do an x and a y-axis, not a theta and a y-axis. And it'll graph the same way. It's just a different variable for your axis. So once you have your graph equation entered, you're going to hit enter. Now, one thing, this is a degree symbol. So you need to go to your mode, and you need it to be in degrees. But I'm going to graph it real quick while it's in radians, just to show you what it looks like. And this calculator may have actually graphed it in degrees. There we go. So the last one, it was graphed in radians, and it did look like a sinusoid. This one is graphed in degrees now. And if you notice, it's just a line that goes very slowly down. It said we want to show the same x and y values as what's shown in our graph here. So the way that you're going to do that is go to Window. What is our x minimum here? -1. And our x maximum we have as 5. You can leave the scale as 1. It'll just do a couple of tick marks in between those. Now our y minimum. We did a y minimum of -60. So you want to enter -60. We did a y maximum of 390. Now the y scale on this one, we only wanted tick marks. How often did we have tick marks? We had them every 90 degrees. So we're going to change our scale to 90 degrees. And so now we're going to graph it. I just realized I made a mistake. I have our x and y min and maxes backwards. The x min is -60. The y min is 390. So the x scale is going to be by 90. The y min is -1. The y max is going to be 5. And then I'm going to do a scale of 1. And my mode is in degrees. And so if you graph it, there's the graph that it makes. Some of y'all may have been looking around when I was doing that, going, she doesn't have it right. And so if you graph, this is basically what it's showing on your calculator, except not even this tall. It's showing about like this. So if you look at your calculator, that's what you're seeing. So that's how you can graph it on the calculator. Make sure when you do your window that you have your x and your y max and mins. You have your x's where they're supposed to be. X's go here and the y's go here. Sorry about that. Okay, so now we're going to be looking at periods. So we've been saying that the period is 360 degrees. And so far, for all of them, that has been true. They haven't messed with the period. It repeats every 360 degrees. For sine and cosine, the period is 360. Or 2 pi if you are in radians. And so the formula that I gave you last year coefficient equaled 360 over your period, or just C equaled 360 over your period, or 2 pi over your period. You need to learn that formula or re-memorize it if you knew it last year. But we're going to use that to be able to figure out our periods. So if this is the formula that you know from last year, then that's where that C is going to go, in between the sine and the theta. It is outside of the parentheses from the theta. You always have it factored out. So we're going to graph this one. And I just said you always have it factored out. And if you look, the 3 is not factored out. So the very first thing we need to do is factor it out of our parentheses. So if I factor out a 3 here, I just have a theta. If I factor out a 3 here, I'm going to have a 45 degrees instead of 135. So that's the equation that we want to graph. So our center line is -10. Our amplitude is 4, so we're going to go up to -6 and down to -14. Our angle is just 45 degrees, and it's a positive cosine. So we're going to go up 45. So our maximum happens at 45 degrees. Now on this one, our period is not 360 degrees. So to go from this maximum to this maximum, we're not going to add 360. We're going to have to use our little formula. C equals 360 over the period. And we're looking to see what is that period. So our coefficient is a 3 here. So 3 equals 360 over P. So 360 divided by P, we can multiply by P and then divide by 3. And so your period would be 120 degrees. So to go from 45, we're going to add 120, and we're going to get to 165 degrees. Last time I was telling you we were going every 90 degrees, but that was because it was 360. 360 divided by 4 gave us the 90 degrees. So on this one, our period is only 120. So 120 divided by 4 gives you 30 degrees. So every tick mark is going to be 30 degrees apart. So if we add 30 degrees, we're going to get to 75. You add 30 again, you get to 105. You add it again, you get to 135. Add it again, you get to your 165. If we subtract 30 degrees, we get to 15 degrees. And if you look, I've got to continue mine a little bit because I didn't go far enough over. So if I subtract another 30 degrees to get right here, that would be -15 degrees. And there's your negative and your positive. So your y-axis actually goes right here in between the two. And so this is our theta axis, and that would be your graph. So if you ever mess up and you don't have enough room, just kind of continue it. And you can erase these if it bothers you and kind of move them over. Just as long as I can tell what everything is, you don't have to worry about erasing it. So now we're going to use the graphing calculator to draw the one that we just did in 7.6. So go to your calculator. We're going to type in our equation, -10 plus 4 cosine. And you can do 3x, not theta, minus 135. And you can do it just like the equation gave it to you. You don't have to have it factored out like we did. And then your window, our x minimum here, we did is -15. And our x maximum we did is 165. And then every tick mark was 30 degrees. And then our y minimum was -14. Our y maximum was -6. And we can leave the tick marks as every 1. And so there's the graph that it would show you. So that's how you can graph it on the calculator, if it ever asks you to do that. Okay, so now looking at exponential functions. They have your variable in the exponent. That is part of what makes it an exponential. y equals b to the x. One thing to note, your b cannot be 0 or 1, because 0 to any number is always 0, and 1 to any number is always 1. And so those make straight lines, and that's not what an exponential looks like. Exponentials look like this, or they may be going down. But straight lines aren't exponentials. So your base can't be a 0 or a 1 for an exponential function. So we want to sketch these two. So the easiest way to do that is just to make a t-chart. Just make a little XY chart. And then we're going to plug in -1, 0, and 1. You can pick other numbers as well. And you're going to plug them into your equation. So 1.3 to the -1 is about 0.77. 1.3 to the 0 is 1. And 1.3 to the 1 is 1.3. And so if you come up here and graph those points, that's about where that point is, and there, and there. And you can keep graphing more if you need to, because kind of right now it looks like a straight line. But it's going to approach the x-axis. It's never going to cross it though. It's just going to approach it, and then it's going to slowly increase. And so that's what that graph would look like for y equals 4 to the x. Again, just make a chart. -1, 0, and 1. If you need more numbers, you can go from there, but these three are the best three to start with. If you plug in -1, 4 to the -1, if you plug in 0, and if you plug in 1, those are what you'll get. So if you go graph it, those are your points, and as you can tell, this one is a lot steeper of a curve. And so there's the graph that it would make. So that's how you can sketch your exponentials. We're going to use a graphing calculator to sketch these exponentials. So you're going to go to your graphing calculator, y equals, and we're going to type in -e. So if you're not sure where your e button is, look over by the ln next to the 4, or near the 4, and then it's the blue. So you're going to have to hit the second button and then the blue. And it does e, and then it has a little box that goes to the exponent, and you type in x. And then you hit enter. Now we need to go to our window. And I'm going to make it back to my -10, 10, 1, -10, 10. And you can also do that on Zoom. We haven't talked about Zoom before, but if you go to Zoom Standard, which is number 6, that'll fix it for you as well. So that is the graph of -e to the x. You don't have to adjust the mode because we're not dealing with sine, cosine, or tangent, so it doesn't matter that it's in degree or radians. It won't change your graph. Now go back to y equals. And I'm going to do it on my y2 so that I can look at the two different graphs. So e to the -x. And again, mine's going to do it in color. If you have one from the classroom, it's not going to do it in color. But it'll show you there is y equals e to the -x. And so that's the graph of those two. So now we're going to do one more example. It asks us to sketch the graph of y equals -e to the -x. So if you're not sure what y equals e to the x looks like, it looks about like that. That's a rough estimate of what it looks like. And then we did the other options of just negative e to the x or e to the negative x. And so now we're combining those two. So does anyone have a guess as to what it would look like, a basic idea? I'll go back to the calculator real quick and show you. Okay. Maybe some of y'all have suggestions that y'all have thought of, but this is what y equals negative e to the negative x would look like. A rough sketch of it. It's not exactly like that, but that's mostly what it would look like. And again, you could do an xy chart and plug in -1, 0, and 1. 0 is going to give you a 1, so that's why we have to go through that point right there. And then you plug in a -1 here, and you plug in a 1, and you get your decimals, and you would just plot them. So if you're ever not sure, you can always do it that way. So that's all on exponential functions. Easiest thing to do is just to make a chart and graph them. So make sure you do your homework tonight, 1 through 25, and then we can go over questions you have for that tomorrow.